All right, we're good to go. So hi everyone, I'm Robert.
I'm Bill.
And welcome to Music Genre Classification. So as a reminder, the goal of our software project was to develop something that could take in a piece of Western music and predict what genre that audio piece was. This is important in a variety of contexts, whether you're Spotify trying to create your perfect running playlist, or you're a DJ in Ibiza trying to host the perfect event. And it's really good that we're having machine learning do these classification tasks because genres can be so ambiguous that only something that's listened to all the data can accurately find patterns. So let's talk about where we got our raw training data from Spotify. We built a web crawler to go through the API and download 30-second audio files. We then took those 30-second audio files and trimmed them down to 10 seconds for the sake of computational feasibility. We took 4,000 clips of songs in total, and those 4,000 songs were split into 1,000 jazz songs, 1,000 rock songs, 1,000 classical songs, and 1,000 rap songs. And that equivalence was done so that our data set would be relatively well balanced.
So initially we did two different experiments to see whether or not these would work. So we first tried training on raw audio using a 1D convolutional neural network, and that did not give us good results. And then we tried using a Fourier transform audio and trained it on using a 2D convolutional neural network, treating each Fourier transform like an image. And obviously that gave us almost random results as opposed to something that's working. So we decided to look for better solutions online. So we came across a GitHub repository that computes the Mel frequency cepstral coefficients, or MFCC. It is a measure of short-term audio power, which is derived from the log transform and also Fourier transform of audio. So we took a time series of MFCC coefficients for every segment of 0.1 seconds in the audio sample that we have. And each MFCC, each set of coefficients is a vector of 52 elements. So when we stack them together along the time axis, we get a 2D matrix for each song sample. So let's go over the basic structure of our software. So in our pre-processing and training part, we first download the songs from Spotify API. We convert it to a NumPy array. We normalize it to eliminate any differences in volume. And we convert it to MFCC coefficients. We then compute the training and validation loops, and then we save the best model. And then for our testing part, again, we take an MP3 file from an external source. We cut it into a 10-second sample so it's compatible with our software. We take it, we convert it to a NumPy array, convert it to MFCC coefficients, and evaluate it using our best model to output the predictions.
So now let's talk a little bit about the model we did use. We ended up going with a gated recurrent unit. So essentially our data would be 100 different time steps of 52 MMFC coefficients. So we threw all of those as sequential data into our RNN, and out of that process, because our hidden dimension was 100, we got a 100 element long feature vector. We threw that into just a single linear layer with 4 outputs, applied a softmax to that output, and then every single one of our outputs represented the probability that our song was of one of our 4 particular genres. So let's talk about how it went in terms of results. We were very pleased with the training and validation accuracy. As you can see, training tops out around 86%, validation around 82, 83%. And the really encouraging thing is that these curves seem to follow roughly similar paths, and training accuracy is slightly higher than validation accuracy, which means no overfitting, no underfitting. But now it comes down for the real test, which is the test set. So on our test set of 640 songs, 160 songs per genre, we had an accuracy of 72.3%. Now for reference, a recent academic paper doing 4-genre classification labeled their benchmark as 63.75%, meaning that we're 9 percentage points better than the academic standard for music genre classification right now. From our confusion matrix, we can see how our model is good and where we can improve. As we can see, rock and rap, it's very good at detecting what those songs are, but if you go to classical and jazz, the model becomes a little bit more ambiguous and it can't really tell the difference between them very well.
Okay, so I guess before we do reflections and takeaway, let me guys show you the demo. So we want someone to give us a song recommendation.
It's odd.
Right now I have Eminem, but we're gonna put something else.
Linkin Park, that's a great idea.
All right.
Yeah. Linkin Park, what Linkin Park song do we want?
Okay, which one?
Numb.
No.
All right.
All right.
Wait, hold on. Bill, get lyrics.
Wait, never mind.
Or
Okay, never mind, found it. So let's just copy this link over to our interface.
okay.
So we're gonna run it.
Now, actually, turn the YouTube video off because it's actually going to play
Yeah, that's
what
the
part
thing.
of the song it's training off of and doing its prediction off of.
Okay, let me go back to the interface. Okay, so while this is downloading, I'm just gonna again like quickly talk about like some of our reflections and obviously like the first thing, the most important thing is having quality data and also, okay, I'm sorry, don't want to interrupt this. Yeah, so as you guys can see over here, these are the outputted accuracies that the song is predicting. So you see the two highest probabilities are rap and rock because like, Linkin Park has like a mix of, it's kind of like a mix of rap, pop, and like rap, rock, and some of these genres. So it's, when there's like multiple, when the song has like multiple characteristics of different genres, it will definitely show up over here in the results.
And if it's more an ambiguous song like Eminem, you get much better results where it's 95% rap or something like that.
That's a very cool demo. Was he planted or not? That really was downloaded.
That was genuinely downloaded from the internet.
And to my ears, that was rock, right? Not rap?
It's so.
Well, no, it's not what they do, it's what they did in that song. What did they do in that song?
So Linkin Park is a rock band, but
Even those 10 seconds?
It had some like rap features to it, like.
Okay. I got all that later. That's a really interesting journey you described, going back and forth from the raw audio to the Fourier transform. I thought the Fourier transform might have got you somewhere. Good old Mel Kepstrom saved the day with their. You know it's a double Fourier transform that's going on.
Wow.
It takes a Fourier transform to the Fourier transform. That's why they talk about Kepstrom, because they inverted the word spectrum. Kepstrom. It's really weird nomenclature. I expected your validation accuracy to be close to your test accuracy, given what you were showing, but it went down a fair bit.
Yeah. We're not 100% sure why. What it could be was that when we were doing the data collection, because Spotify doesn't have very good APIs for selecting songs, it all had to be done manually. And so when I went to the test set, I decided, let's pick out some, to reduce the chance that you have duplicates and you backtrain on your validation data, let's go to some more obscure playlists with rock songs that are not going to be found in my validation set. And because of that, I may have stumbled on some niche subgenres that are slightly different from.
There's a quick way to say that, which is your test set may not have been drawn from the same distribution as your validation set.
Yeah.
So, okay. Harris? I'm good. Question from the rock fans in the audience?
Can you go to your precision? I'm wondering if you took just the highest precision, or is it average, or is it an average precision? Because you showed a mix of like precision and recall.
Yeah.
How you got your precision.
So the precision and recall were computed for each genre. So we looked at the precision just for jazz, or just for rock, or just for rap, where we said, okay, let's compute across all the false positives for a particular genre, and then let's compute across all the false negatives for that particular genre too. So that's how we got each of these. This is the precision particularly for classical, and that's the recall particularly for classical.
Great. All right, thank you.